Hey everybody, Mr. Regan here, and we're going to be looking at one of our last sections here, part 4, that deal with real-world application of force and motion. And these were the questions on the summative that dealt with the different objects as they slide across a floor or a table, and this idea that as they gradually slide across, they slow down and stop after 10 meters. And the question is, why did this block stop moving, or in this case, the salt shaker? And again, we're going to dive into our simulator, kind of get an idea here about why something would stop moving. So in our simulator, anytime we run our simulation, you'll notice our object here will move and move and move and move until we really just stop it, right? Nothing's going to stop our object unless we do, okay? Unless we pause it, unless we add a force, unless we do something to change it, okay? Every object needs a force applied to it in order to change its velocity. And that goes for all things unless we're in a situation, or in this case, a simulator, where we can simulate no forces. So whenever we run our simulator all by itself, what we're really simulating is an object with a specific velocity that's experiencing no force. So our object experiencing no force, and we'll continue on and on and on and on. Again, unless we apply a force, and then we can change it in some way. We can speed it up, we can slow it down, we can cause it to stop, start, and all those different examples. So the question then becomes, well, what force is causing our object to stop moving? Well, anytime something slides across a surface, especially on Earth, okay, typically we have friction. So anytime an object slides, there's always going to be a force applied in the opposite direction that's going to cause it to slow down. Okay, notice we had an object traveling in one direction. Friction was applied in the opposite, causing it to finally come to a current velocity stop of 0. And as we slowly recap, it'll always have that force applied, that small amount of force, until it comes to a stop. So we always need a force applied to an object in order to change its current velocity. So let's take a look at what our answers and options are. Okay, the floor exerts a force that is opposite to the direction of the block and the motion of the block. Well, there it is, right there, right off the bat, letter A. Okay, the block ran out of force. Well, you can't run out of force. A force is exerted, and that force will cause a change. The floor absorbed force from the block. You don't absorb force, you exert a force. It's applied, push, pull, that sort of thing. All objects stop moving because their natural state is to be still. Bad science. Bad science. Don't put that. So there's your answer. Go ahead and take a look at this next one. See if we can kind of figure it out. If you have questions, reach out. Otherwise, good luck.